Hello everybody, welcome back to Mathlete's Corner. In this video, we are going to continue with our combinations and permutations series, and this will actually be our last video of the series, level 3. So let's get right into it. Alright, so our first problem is the 2017 AIME 1 problem 7, and it reads, for non-negative integers a and b with a plus b less than or equal to 6, let t of ab equal 6 choose a times 6 choose b times 6 choose a plus b. Let S denote the sum of all t of ab, where a and b are non-negative integers with a plus b less than or equal to 6. Find the remainder when S is divided by 1000. Now, in order to tackle this problem, let me introduce you or remind you of an interesting property. So let's consider this as a mini question. Let's say we're taking the sum instead of 2 choose A times 2 choose B times 2 choose C. And 2 is just an arbitrary number in this case. You could take any number. I just wanted to use a smaller number just so that it's easier to understand. And let our conditions be A plus B plus C equals 3, and A, B, and C are all integers from 0 to 2. So how would we find this sum? Well, what we can notice is, say we have 6 objects, and I will represent each object with a square. Now, out of the first 2 objects, this is taking A of them. So 2 choose A will choose A out of our 2 objects. Similarly, 2 choose B will choose B from our next 2 objects, and 2 choose C will choose C from our next 2 objects. So in total, since we know that A plus B plus C is equal to 3, we're choosing 3 out of 6 objects. And every way that we choose 3 out of 6 objects is being counted once and only once. So our sum will just come out to 6 choose 3. So the total number of ways to choose 3 from 6. And that comes out to 20. Now remember, this is just our mini problem, just to get an idea of how we can approach our actual AIME problem. But the catch here is that A, B, and A plus B don't have a common sum. So that makes things a little bit more challenging. But what we can notice is we can apply a very special property that we are already familiar with. So we can say 6 choose A times 6 choose B times 6 choose A plus B is actually the same as 6 choose A times 6 choose B. And here we'll just replace 6 choose A plus B with 6 choose 6 minus A plus B, as shown here. Now we notice that when we add our 3 numbers in the lower portion of our combinations, A, B, and 6 minus A plus B, they add up to 6. Now when we take the sum of this over all pairs A and B that satisfy the conditions in the problem, this will just come out to 6 plus 6 plus 6, which is 18. Choose A plus B plus 6 minus A plus B, which is just 6. And when we calculate this, it comes out to 18,564. Now, the problem is asking for the remainder when you divide this by 1,000, so our final answer would be 564. Our next problem is the 2022 AIME 1 problem 9. It reads, Alina has 12 blocks, 2 each of red, blue, yellow, green, orange, and purple. Call an arrangement of blocks even if there is an even number of blocks between each pair of blocks of the same color. For example, the arrangement, and the arrangement shown here, is even. Alina arranges her blocks in a row in random order. The probability that her arrangement is even is m over n, where m and n are relatively prime positive integers, And as usual, in every AIME problem, we have to find m plus n. So what we can notice is when we have our 12 spots here, we can separate the spots into odd numbered spots and even numbered spots. So here, let's say that we want to satisfy the condition given that there's an even number of blocks between pair of blocks for the same color, but let's start with just one color. So let's say red, and we want the number of blocks between our two red blocks to be an even number. Well, we'll notice that we need to have our red block in one of our box locations or our odd numbered locations, and we need to have a red block in one of the unboxed or the even numbered locations. Otherwise, there will be an odd number of blocks between the two red blocks. Similarly, this has to be satisfied for every color in order for our arrangement to be considered even. Now that we have this observation, we can just proceed with our calculations. So there's 720, which is 6 factorial, ways to decide which color goes in each of the odd numbered spots. And similarly, there's another 6 factorial or 720 ways to decide for the even numbered spots. And our denominator for the probability will just be the number of ways to lay out all of the blocks in any order. So we have 12 total blocks, so that gives 12 factorial, but we have to divide by the number of times we're repeating arrangements. So for example, if we switch two reds and get the same arrangement, we're counting it as different though. So we have to divide by 2 for each of our colors. So we're dividing by 2 to the power of 6. Now when we do this, we get in the numerator 6 factorial times 6 factorial times, and then the 2 to the 6th in the denominator of the denominator will go to the numerator. So that's times 2 to the 6th all over 12 factorial. And we can further simplify. We get 6 factorial times 2 to the 6th over 12 times 11 times 10 times 9 times 8 times 7. Now this 720 and this 720 cancel. Here we can cancel a factor of 4, so we are left with 2 to the 4th. And here we'll cancel a factor of 4, so we're left with 3. And this comes out to 16 over 3 times 7 times 11, which is 231. And when we add our numerator and denominator, we get our final answer of 247. That's all for this video. Thank you for watching. Don't forget to hit that like and subscribe button, and we'll see you next week here at Mathlete's Corner.